Hello and welcome. So this is the problem from the Cambridge mathematical examination, which is the Cambridge triples. And here in this video we are required to compute this definite integral, and one natural thing that comes to mind is to try to separate them, because you obviously have the integral from 0 to infinity of an x squared, then you have a log of 1 plus e to the x minus e to dx, then it will be the integral from 0 to infinity of an x to the third dx. But the problem now is that this is divergent, this diverges. Okay, this also should diverge because both of them are infinite as x tends to infinity. So this usually happens for many definite integrals. So it happens that sometimes the integral you are trying to solve, okay, like if it contains a difference, they may diverge. Let's say you are trying to integrate from 0 to infinity, or let's say 1 minus cosine of x divided by x dx. So if you maybe separate them, they will diverge, but when you combine them, they will now converge. You understand? So sometimes whenever you are dealing with infinite limits, or even if the limit is from 0 to 1, before you separate definite integrals, you have to be careful so that you don't start doing nonsense and probably feel discouraged, because you have to check if they are convergent but combined together, because we know that infinity minus infinity sometimes can converge, sometimes may not converge. So that's why it's called undefined. So now that separating does not work, what should work for us? Okay, another thing that comes to mind is that maybe just take u to be e to the x, but problem now is that you're going to write the x to be log u, so this x square will be a log square u, and this again is not easy to handle. So what we're going to do is that we're going to use a trick that we know that the logarithm of e to the x is actually equal to x. Okay, so essentially, basically, you are going to write this integral. So this integral will become the integral from 0 to infinity of x squared times the logarithm of 1 plus e to the x minus the logarithm of e to the x, okay, dx. So you will end up with the integral from 0 to infinity of x squared. So you have a logarithm of, you can divide, so you have a 1 plus e to the x divided by e to the x dx. Now you, of course, you could write this as, sorry about that, so you could write this as the integral from 0 to infinity of x squared. So you have a logarithm of 1 plus e to the negative x dx. Okay, so this essentially tells us that we are making some good progress, because now we have a log term, and the only thing we can think of now is the series for logarithm. And because we have a e to the negative x, we can use the series, because we know that logarithm of 1 plus x has a series only when x is numerically less than 1. So in this case, the series will be the sum as n runs from 1 to infinity of negative 1 to the n plus 1 x to the n over n. So it has a series in that case. So now this will be equal to, so now this means that if we take x to be e to the negative x, this will work out for us, because e to the negative x is actually numerically less than 1 between the limit from 0 to infinity. Okay, so basically we have to write this as 0 to infinity of x squared times, now we replace this by the series as the sum as n runs from 1 to infinity. Now we have a negative 1 to the n plus 1, but then you have e to the negative nx all divided by n dx. Now we can swap summation and integration, and you get this is the sum as n runs from 1 to infinity of negative 1 to the n plus 1 over n times the integral from 0 to infinity of x squared e to the negative nx dx, and this would equal the sum as n runs from 1 to infinity of negative 1 to the n plus 1 divided by n. Then you have gamma of 3 over n to the third power. Now, one question you may ask is that why do we say this? Why do we say this is equal to gamma of 3 over n cubed? Well, It's actually straightforward. Generally, gamma of n over a to the s power. Okay, let me just put it. We know that gamma of s is defined to be the integral. Oops, sorry about that. We know that gamma of s is defined to be the integral from 0 to infinity of t to the s minus 1 e to the negative t dt. Okay, so now let's look at this integral, which is the integral from 0 to infinity of x squared e to the negative nx dx. Let's make some substitution here. Let's take t to be nx, and if we do this, let's see that dt over n will be dx, and not just that one, the limit of integration remains the same, so that is settled, but x then will become t divided by n, and what else? I think we are good. Yes, we are in good shape. So basically, sorry. So basically, you would have this integral would become, first of all, you have 1 over n times the integral from 0 to infinity of t over n all to the second power e to the negative t dt. So that would be 1 over n to the third power times the integral from 0 to infinity of t squared e to the negative t dt, and that would be gamma of 3 over n to the third power. So you see where we get that term from, but this is actually a very standard technique. I think it's 1 over gamma of n over a to the s is equals to the integral from 0 to infinity of t to the s minus 1 e to the negative at dt. I think this is the general formula for it. Yeah, recall, and I've also used this to solve many problems on my page here before, so I think this should be it. So that is the formula I used. So when I came here, I did not really memorize this solution or anyway. I just knew that this is going to be the answer. So when you solve all these problems, at some point you start to see patterns. So now we can, gamma of 3 is 2. So this will be twice the sum as n runs from 1 to infinity of negative 1 to the n plus 1 all divided by n to the fourth power. And this, we could write this is twice eta of 4. Okay. This is twice eta of 4. And eta of 4 have a representation. This is twice 1 minus 2 to the negative third power zeta of 4. Okay, so that would be twice 1 minus 1 over 8 times pi to the 4 over 90, right? And that should give us a 7 over 4. So that is 7 over 4 pi to the 4 over 90. So that would be 7 pi to the fourth power all the way by 360, I believe. Yes, because 2 times 90 is 180, then 180 and 180, that is 360. Yes, 360. So that is that. So thank you very much for watching, and please do subscribe to the channel. Thank you and have a nice day.